Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to build some predictive models using deep learning, and we're using the framework Tensorflow. So let's understand what we mean by deep learning. So deep learning, as you are seeing from this diagram, is a subfield of machine learning, right? Which is also a subfield of artificial intelligence. So artificial intelligence, coming from two words, artificial intelligence, is a technique in which you are trying to enable machines, right, to mimic human behavior or human intelligence. And there are several subfields. One of them is machine learning, in which you are trying to use several algorithms, several statistical methods to enable machines to improve with learning or with experience. So when you feed them data, they learn from the data, they get experience and able to do or behave like humans. Then under machine learning, we have another subfield called deep learning, which is a subset of machine learning which makes computation of neural networks, right, feasible. So in that case, we are trying to learn or imitate how the human brain thinks, right? So inside everybody's brain, we have something called neurons, right, or nerves, which is something like this. Let me show you an example. Right, so everybody has this thing called neurons, right, inside your brain, right? You and I have this thing. So the neuron, right, or the nerve consists of the cell body, it consists of the dendrites, and then it's going to have an axon and then terminal axons, right? So these dendrites are part of the nerve that are connected to different parts of the body or connected to another nerve, and they receive electrical signals as input from those places and then move it towards the cell body. So inside the cell body, we have the nucleus, we have the DNA, we have all the different chemical reactions, and they understand the impulse and then they generate another form of impulse that is sent away from the cell body to the next maxilla or to the next neuron or the next nerve to make or produce an activity, right? So that is the basic concept. So you are trying to mimic how the brain, how you and I, our brain with the nerves work. And so the same concept is termed artificial neural network, right? So you're trying to build something artificial, not God-made, but man-made. So just as we have a neuron or a nerve with a cell body with dendrites, the same way an artificial neural network is having an input, which is like the dendrite, to receive signals from different parts of the body, right, which is the inputs, and then it's going to pass through all of these weighted stuff, which is going to be the different computations, come to the cell body, which is similar to the where we have the sum and activation function, which is going to combine activation function, is going to combine all the sum the entire inputs coming, pass it through different algorithms, and then produce an output, right, which is going to be like the same thing. So the impulse come towards the cell body, the activation function, the summation, everything occurs here, and then now it is optimized. Then the result is sent away from the cell body as an output to another muscle, to another nerve, right? That is the basic understanding behind neural network. So that is how we think, that is how we behave using neurons. So we are trying to do the same thing, but this time with computers, with machines. That is the basic understanding. So there are different types of neural network, several of them. So these include, as you can see, I have an image of them with a lot of different neurons. We have several types. So we have the simplest one is what we call the perceptron. So the perceptron is just a single layer neutron, which is having the input and then the output, right? A perceptron. We also have feed forward, which is going to have the normal input. The yellow ones are the input and the green ones are the hidden layer. Then the orange is the output. So it's going to be going one way, right? One way directional. We have several types. We have RNN, we have LSTM, which is a form of RNN. We have convolutional neural network. There are several of them, as you can see from these images. Right? You have deep forward, we have gains, we have there are a lot of different architectures for neural networks based on the problem you have and based on how performant you want it to be, right? There are a lot of them, right? And new ones are being developed as time goes on. Okay, so don't let this thing scare you. It's just something about how the architecture of it, because in the brain we have different forms of neurons. So in the same way, we are trying to have different forms of architecture for the neurons, right? Be able to do different tasks. Okay, so how do you know which type of neuron to choose, right? Or how do you know the type of neurons and what to use it for? So these are the types of neurons and then the applications. So this is something simple to help you with that. So we have the neural network, we have the data type you want to work on, and we have the application. So in case you are trying to do anything that is tasks that is inside a table, a tabular format, which is numbers or categories, or it's a classification problem or regression problem, you can use multi-layer perceptron, right? Multi-layer that is having different layers type of neural network, right? So it can be used in case you have this particular type of data or this particular type of problem. So some of the applications can be voice recognition, machine translation like Google Translate, and different types of classification problems or regression problems. In case you are also working with images, right, or text, right, you can use CNN, which is convoluted neural network, which is very useful in case you are trying to work with images or text or video, which is images anyway. That is moving images is video. So in case you have anything that has to do with images or text, you can use CNN, right? And CNN are very useful, and some of the applications can be for video and image recognition, like face recognition, video surveillance, all of these things, computer vision stuff, right? If you are doing anything computer vision, CNNs are very good for that. It can also be used for NLP because still test. It can also be used for recommendation or recommender systems. The other types of neural networks we have is RNN, which is very useful in case you are working with test data or in case you are trying to do something with time series. It's very useful. So in case the applications can be for NLP, since there's test, can also be for time series, for test classification. So if you are doing sentiment analysis, test classification, binary test classification, one of the best ways is to use, one of the best neural network architecture to use is to go with RNN. There's also a subset of RNN, which is LSTM, which is a form of RNN, which is also very useful in case you are trying to work with test, right? So very useful for NLP. These are not all of them. There are different applications, but this is just to help you have an idea of which type of neural network architecture to use, the type of data format you'll be expecting as an input, and then the application where we can use them. Because I prefer to understand what I'm doing and then where I can use it, right? Because that's the most important thing. Okay, then there's also another format of neural network architecture, which is sequence to sequence, right? Sec to sec, which is in case you're working with anything, any format of data that is in the format of a sequence, which almost every test is the format of a sequence. You can use sequence to sequence, all the different architectures of sequence to sequence neural network. So it is very useful for chatbots, for machine translation like Google Translate, like question and answering system, and several NLP tasks. So these are some of them, not all of them. So let's move on from these types of neural networks and the applications to know how to the components rather of a neural network. So as we saw from the diagram earlier on, here we had these things. So these are the components of a neuron. It's having the dendrites, it's having the cell body, the axon, and then the external or terminals. The same way every artificial neural network is having components. So the components of these neural networks are these, right? So this is very important to help you know not just the components of these neural networks, but how to choose a number of nodes and then layers. So by default, this is going to be the input. So the input is going to be the first layer. Let me show you different pictures. Okay, so this is the component of every neural network. So we have the input layer, right? We have the hidden layers, and we have the output layer, right? So the input layer has different neurons. So these dots are neurons or nodes, right? Nodes, neurons, perceptron, they're all the same thing when it comes to deep learning. And then all of these things connected together forms a network, so it is called a neural network, right? So it's a collection of nodes or collection of neurons to form a neural network. So all of them have these main components: the input layer, the hidden layer, and then output, right? So for the input layer, it is in case you want to know how to choose the number of nodes and how to choose the number of layers and what every layer does, the input layer is usually the number of features, right? So if you take any data set or any data, so the input layer is going to be where you're going to be is always equal to the number of features, right? So the input layer is going to consist of several neurons, and these neurons are going to have dimensions, and the dimensions is the number of features you have, right? Or in some cases, the number of features you have plus one. So the plus one is to help you in case you are trying to compensate for bias, right? So in case you say you have a data set with 4 columns, it's going to be the 4 let's say a data set with 5 columns with 4 columns as the features. The 4 columns, right? 4 is going to be the number of neurons, right? The number of dimensions, right? So it's going to be 1, 2, 3, 4, right? That is going to be the input. Very simple. And then you can add 1 to it for bias. So the input layer is always the number of features, right? Or the number of columns, or the number of features plus 1 to compensate for bias. Then you also have the output layer. So the output layer is the number of classes you are supposed to predict, the number of targets, right? So in case if it's regression problem, every regression problem, most of the time we just specify the output layer as 1, right? Because it's always going to produce one value at a time. Then classification problems can also be binary, or it can be multi-label classification problem. And then if it's classification, you can also group it like 1, right? Or the number of classes or targets, especially if you are trying to work with softmax. That is a basic understanding. So input layer is mostly equal to the number of features or the number of columns you have, which is going to be the input dimension. The output layer is going to be the number of classes. If it's regression, it's mostly 1 because they are presented only 1. If it's classification, it can be 1 or it can be 2, or based on the activation function you are using, right? So like softmax. Okay, that is a basic understanding behind it. So this is a simple image to help you know the component of a neural network, and then how to choose the number of nodes, right? These ones are the nodes or neurons, and the number of layers. So how do you choose the number of layers, right? It depends upon you, especially for the hidden layers. There are several talks somewhere. I'm not an expert, but the experts have different arguments and comments on how to choose the number of hidden layers. But a simple understanding behind how to choose the number of hidden layers by Jeff Hedon, one of the experts in deep learning, is to choose a number between the input and then the output, right? So that is always, you should always choose a number between the input and output, or finding the mean of them and choose as your number of hidden layers. Then to know the number of nodes to use, right, you can just use this simple formula. So the number of hidden layers is always, right, for the number of hidden layer or the number of nodes to use is always equal to, for the hidden layer is equal to the sum of the size, right, the sample size of the entire data set you are trying to work with, divided by a constant called alpha, which can be between 2 and then 10. Most of the time 2 is better, or 5, times the number of inputs, right, the number of inputs layers you have here, the number of inputs neurons, plus the number of output layers. So this is a simple formula to help you know how to choose the hidden layer, right? The number of nodes for the hidden layer and the number of hidden layers to use. Very simple. So let's move on from this, too much of the talking, to how to work with our task, right? So I'll just go back again to our workspace. So by the end of this tutorial, I'll be trying to see how to build some predictive model, and we are going to use a machine learning. So this is a particular data set you're trying to do. Our task is to classify. It's a classification problem, as you can see from here, right? And then our task is to predict if the client will subscribe a term deposit, right? Variable y. So this is having about 17 different attributes. That means that it's going to have a lot of features. These are all of them, right? So I'll download the dataset and you start from scratch. So I'll go back to the data folder. You can use the iris dataset if you want, but let's go with this. And then I'll just download the dataset, right? You can use this one or this one. Perfect. So we'll be using Colab to help us with our task. So I'll just go back again to Colab. The reason I'm using Colab is that it's easy, right? It keeps you better. So let me modify this one. So this is going to be, I don't know whether the audio is okay. Let me know if the audio is okay. And you have any question or contribution, you can also put inside the comment section below, and check our Patreon channel for some cool stuff, as well as our Udemy courses for some cool materials. Okay, that is some simple promotion. Okay, so let's go back. So this is going to be my Tensorflow. So let's call it as deep learning project with Tensorflow, right? That is something simple. Okay, now let's start with what we're doing. So this is going to be a simple task we are trying to do. Our task is that we are trying to make some prediction, build a predictive model using this particular data set coming from here. It is going to be our task, right? So I'll copy this one and then I'll paste it here. So this is going to be our task. So I'm going to call this my deep learning project with TensorFlow. We are using TensorFlow because there are several libraries for deep learning. We have low level, we have high level. So some of the low level are Theano, MSNet, PyTorch, Torch, and then TensorFlow. But we have some high level such as Keras. But the Keras TensorFlow 2. So these are some of the low level. So low level frameworks, right? Deep learning frameworks that we have. Yeah, we have these ones are just to help you. We have Theano, the first of them. We have MSNet. We have Torch, and we also have PyTorch. And then we have, of course, TensorFlow. TensorFlow 1, right? Perfect. But for the high level, which makes it very easy for us, this one you have to write a lot of codes. This one you have to write a lot of codes, but this is high level, which is making it easy for everybody. If you understand Python or something, it makes it easy. We have frameworks. So an example of this high level one, we have Keras, right? And then on Keras we have TensorFlow 2, right? So because this TensorFlow 2 is built on top of this, right? Very simple. So these are some of them, but not all of them. We have Cafe, we have Latte, there are a lot, right? But this is what we're trying to use. So let's see our project. So this is going to be our project, and this is going to be our task. So our task by the end of this tutorial, our task is to, right, we are going to do a classification, right? So it's going to be the data is related with this. Is going to be our task. As prediction of term deposit, right? Using TensorFlow, using deep learning. Let's call it deep learning. So this is going to be a very long tutorial, so apologies for the noise you may hear behind, and this is going to be the description, right? Something very simple. Okay, so let's, and this is going to be our dataset. So let me put the datasets here. So dataset, which is going to be here, so that in case you have it, you are coming from the future, you know where we took the dataset from. Okay, perfect. So that's something very simple. So the packages we'll be using in this wonderful tutorial that we'll be using TensorFlow. So in case you don't have it, it's going to be the packages requirement. We'll be using, of course, we use scikit-learn, very important. We'll also be using pandas, and then NumPy, and then we'll be using TensorFlow 2, right? TensorFlow 2, and then we may also use all the processing libraries, Seaborn, and then Matplotlib. Then you can also use TensorBoard, right? So these are the packages we'll be using for our task. So let's start from scratch. So starting, let's go back again and start. Right. So I'm going to start with it. It's going to be the first part. So the first part is going to be our data preparation. Let me show you the workflow. Go back again to our diagram here. I want to show you the workflow for our task, right? So in case you have any question or contribution, you can let us know. This is going to be our workflow. So the workflow for our task, in case you are trying to work with TensorFlow for deep learning, that you first of all have to prepare your data set, prepare your features, do whatever you have to do, your processing. Then after that, you feed it into your model. So this is the steps for building a model. You must first define your model, right? Because it's a neural network, you must define the architecture of the model, which can be sequential, it can be functional. Sequential is going to be, you are going to build your models layer by layer, right? Step by step, sequence by sequence. Or it can be functional, which is more complex, right? But you'll be going with this. You don't want to go to this. Then after that, we are going to compile our model, right? And then we are going to fit our model to our data set, right? So that it learns the patterns from it and recognize the patterns from it. And later we're going to evaluate our model. If it is not good, if it's good, we tune it and then make it better. Then later we're going to serialize it, productionize it, and then send it outside. Then you can monitor, right? So this is a basic workflow. Something very simple to keep in mind. So let's start with the first one, preparing our data set. So I'll go back again. It's going to be data preparation. So first of all, since we have a data, we're going to read our data, and we're going to encode the data, right? Encode data, right? This is part of feature engineering. We can also do all of these feature engineering to do and then as we said earlier on, feature engineering consists of, let me make it like that. Let's bring it here. Feature engineering, we encode the data, right? And then we just do it. Feature selection. The first thing, it's not the first thing. Is the first thing is feature creation, feature extraction. These are the components: feature extraction, feature selection, feature creation. This is mostly automated, right? Automated feature engineering, right? And then the next one is going to be feature storage, right? That is the newest one, new in town, newest, right? So this one you can use feature store. This is very important, right? Newest. Okay, so that is the basic stuff that we'll be doing. Then after that, we're going to split our dataset, right? Perfect. And let's start with this. So that is a basic workflow for the data preparation stage. So I'll just go back again, and then we start writing some code. So in case you have any question, let us know, and in case I'm talking too fast, let me know. Right. Okay, so let's load our libraries. It's going to be our packages that we're using. So we'll be importing pandas as PD, we'll be importing numpy as NP. So what's the name? Google Colab has some very nice stuff that makes it easy for us. So all of these things are already there, so we don't need to worry about it. So let's go with the ML packages. So from sklearn. Now, one thing I have to talk to you about is that deep learning is not just for TensorFlow, right? You can also do some deep learning stuff with scikit-learn. So that's what you're going to be using. So scikit-learn, you'll be going with from sklearn. You can also go with some other packages here, right? We have our model selection. Okay, so this is a package to be using. I hope everybody can see it well, right? So for deep learning packages, right, we'll be using TensorFlow, but you can also use scikit-learn. So let's go with the scikit-learn first. So from sklearn we have the neural network, right? So there's also a neural network sub module inside scikit-learn, which we can also import the multi-layer perceptron classifier, right? So these are the packages we're using. I'm importing all of them. Yeah, right. So in case you don't have it, it's automatically going to be installed, but I think by default these things are mostly installed already on Google Colab, right? Perfect. Now let's go for the TensorFlow. This is going to be the deep learning TensorFlow package. So in case you don't have it, TensorFlow, you can just go with this option. So it's going to be my bar pip install TensorFlow, right? So that's the first thing. Also need to install the pip install TensorBoard. It's going to be TensorBoard, right? So this allows you to be able to do some visualizations, right? So these are the packages we'll be installing. So just use the exclamation and it's already going to be installed for you. So the version of TensorFlow we are using is 0.2. As you can see from here, it's taking some time for it to install. So in case I want to check for the version that I'm using, by now everybody's using 2, right? Keras API. Just check for version. Going to be my tensor. So let's import it. So import TensorFlow, right, as tf, as you can see from here. Then print tf.version. So this is going to give us the version, right? If I make a mistake here, so this is the version we are using, right? So that in case you are watching it from the future, you know we are using the Keras part, right? The higher level API. Perfect. So let's work on our dataset. So let's load our dataset. I'm going to go with df.pd.read_csv, and I'll be passing in my dataset. So the dataset, we have it here already. So the dataset is already here, right? And I'm just going to go to my Bangladesh now. I'm picking this one, right? So to upload it, I just go back again, and I just go back to the sidebar here, table of content. This is what you have done so far. In case I want to get it, I just come back here. They give me the option of uploading it. So in case I want to upload it, I just go back again and upload the dataset here. And one thing is that if you are uploading it here, once you close this session, it's going to go off, right? So I'm just going to go back to my, we have a deep learning tutorial, we have data, and inside my dish now, I'm going to pick this particular dataset. I'm using the full one. I'm going to upload it. It's about 5 megabytes. Okay, so that's the information they're giving to us. So after it has finished loading it, you're going to see it here. So let's go back again, go to bank, additional full.csv, and this is going to be separated by this option, right? So it's uploading it, taking some time. So once it's finished, you're going to see that it's yellow. So that's finished uploading it, and you're going to see it here, right? Perfect. So that means that it has uploaded it. Now let's load it. That's it. So I'm going to run it. It has loaded it perfectly. Let's check it out. So this is going to have a lot of work you'll be trying to do, right? I've not encoded. We are doing everything from scratch. Perfect. Wow. So most of them are categorical. Most of them are, wow, and there are even negative numbers there. So what we may do is that we may take off some of the negative numbers to make our work easy for us, right? We can just do feature engineering, feature selection to select the most important feature, but that's going to be too long, right? So let's pick and work on our data set. So let's check with the size of it. It's going to be df.shape to get the size of our data set. This is very important because the size of the data set can be useful in case you're trying to work with the batch size, the batch mode, and then the epoch, right? Very, and a number of iterations to go, right? So the size is very huge, right? And there's a number of columns, the number of features you're working on. So let's select, first of all, let's do some check data type, as we always do with df.d type to get a data type. So d types, not d type. Perfect. So most of them are objects and some of them are integers, so we need to be able to get only the categories out, right, and do some encoding for that. So how do we do that? So this is going to be let's go straight away to feature engineering. In this case, we're trying to encode our data, right? Encode data set. So because every ML algorithm or deep learning requires numbers, they require numbers, not strings, right? So we have to make sure that we are trying to do that. So how do we do that? So let me put this one here. I have to put a test to make it look nicer for the future people, right? Okay, so how do you do that? So we're going to be encoding our test, right? That is the thing we'll be doing, encoding the data set. So we need to get all the categories and all the rest. So I'm going to pick only the category data set. So categorical, right? So today I just go with my sample. Let's go to num cat columns to get all the cat columns, and just go with this option. So df, right, dot select d type, right? I'm going to specify what I want to include. You see the format is going to go with the include. I want to include into this particular place. I want to get only the object, right, and then the categories, right? How do you spell category? Yeah, so this is going to give us only the object and the categories. If I go back and I check it out, only the object columns have been given to us. So these are the categorical columns, right? Perfect. That is what we have. So these are the ones that you'll be using, right? Not the rest, only this one. So I have to just go back again and get only the column name. So dot columns, right, dot to list, right, to get it as a list. And as you can see, these are the only ones there, right? We have to take off this one. We will be taking off the y because the y is not part of the features. It's a categorical, but we need to take it out. So I'm just going to do the same thing here, copy this to get the y out right away, and then do it again so that we get the y out, because the y is not part of the categories, right? It's a target. Perfect. Now let's get the numerical columns. So numerical columns we have, so it's going to be the same thing we did here. So let's copy this here and modify. So this is going to be my num columns. It's going to be the same thing we did, but this time I'm going to change it from, we can simply do exclude, right? Exclude. So this is going to exclude them. So anything that is not object or category is going to be part of the num columns. I don't know whether you can see it, or I hope everybody can see it, or I hope it's not too small. Okay, this is better. Apologies for it being small, right? So these are the ones. Perfect. So now let's get the features. We have gotten these ones. Well, we need to be able to get our label. So this is going to be our encoding for the label. So encode, so label encode target. So the target, as we saw, is this particular column here, and the dfy is no, and yes, which is like binary, right? So in case I want to encode the simplest format, just go with this .map .unique rather to get the values. So this is going to give me the values no and yes. So I'm going to give no as 0 and then yes as 1, right? So how do we do that? So we can just come down here, and I'm just going to go with this option. So .map, pass in a dictionary. So no is going to be 0, and then no is going to be 0, and then 1. Yes is going to be 1, right? So if I go with this, it's going to map the entire stuff and give us our result, right? So I'm just going to equate this one to the dataset, right? Perfect. So now everything is working as expected. So what we have to do is that we have to encode these categorical values, right? And then numerical is already encoded. So numerical is already encoded. So let's do that one. So how do we encode the numerical? This is going to be my feature encoding, right? So this we are trying to do it for only the categorical. We want to just do it for only the categorical. So sometimes the simplest way is to use you can use pandas. There are different methods. You can use pandas. You can use scikit-learn. So let's use scikit-learn. So we have already encoded it. I'm going to call it as my ordinal encoder. So odd encoder, right? Then I'm just going to go with my ordinal encoder, which I have already imported. Ordinal encoder. Perfect. That is the simplest stuff, right? And it's going to go straight away with this option. So before we encode, let's make a copy. So let's call this one as df2 df.copy, right? So that we have a copy. So this is unencoded copy, right? Unencoded, and it's going to be the raw data, right? So this is just a copy, and now we'll be encoding the entire stuff. So to encode it, I'm just going to go with my df. I'm going to pass in all my cat column, so the cat columns that we have. So if I run it, it's only going to give us only the categorical columns that we have, which is all of these things, right? Which is a lot. Then to be able to encode them, some of them can be binary, but with this option is going to be easy, right? So this is it. So I want to encode it again. So I'll copy this one here, come back. I may change the theme to make it black. Anyway, don't worry. So I just go back again to this. Then to encode it, I just go with same thing we had, right? I'll pass in my odd encoder. I'll just go with my fit transform. I'll pass in the entire dataset. So this is something very simple. So this is going to help us to encode our dataset and put everything back. So I'm going to encode everything back. So if I go back and I check it out again, so everything now is numbers, right? Everything now is numbers, as you can see. Perfect. So we have encoded them. But that's what I was saying. We have to take these negative values out. And it's going to affect our work. Right? It's going to affect our work. And then as you can see, some of them are good. Yeah, some of them are good, but we can actually scale them, normalize them, do all of these things, which is up to you. So in case I want to get all the categories back. Categories. Oh, I can't spell categories, right? How do you know which number was it? I just go with my ordinal encoder dot categories, right? I go with this, going to print the entire stuff for us, so you can know which all of them are. So admin for every column, right? Very simple. That is the basic overview of it. Now you have seen how to encode our dataset. So as I said, we can actually take some of them out. So let's plot them. So let's do a simple plot of the entire stuff. Some data visualization. So data, let's use Markdown. So we have encoded the dataset, right? But we can also do feature selection to select the most correlative feature. So this is going to be my data visualization. I can't spell today. Visualize. Yeah, let's keep it like this. Visualization. It's so funny. So now we'll be using Seaborn to help us with that task. We already imported Seaborn, so it's going to be import Seaborn as SNS. Then you go to be importing matplotlib.pyplot as plt. I love Colab. It makes it work easy. So let's plot our dataset. So the first one is going to be my target distribution. Is it balanced or not? So it's going to be my df. If I go with df dot go with the y, I want to check if it is balanced. So if I check it out, you can see from here that it's okay. It's not that bad, right? Because you are trying to find people who are going to do a term deposit, which is not most of the time common. Then in case I want to plot the entire stuff, I can use Seaborn to plot it. So sns.count plot, and I'll pass in my s is going to be my y, and then the data is going to be my df. So let's check it out. And from the picture you can see that it is imbalanced, right? This is very, very imbalanced. You can actually fix this issue, but let's move on. Like, you can do that later. Let's move on. Okay, perfect. Now do some, we have seen how our distribution, this is actually imbalanced, as you can see from here. This is not balanced, but sometimes, yeah, this is the simple narrative of this, that this is imbalanced, right? So the simple narrative, in case you want to know what the percentage of it, right? In case I want to know the percentage of this one, whether it's balanced or not, I can just come down here. Let's add, let me show you how to do that. So sometimes, yeah, it can be imbalanced, but you can still use it like that because it is financial data. Sometimes, right? Financial data can be, because sometimes you are trying to check for anomaly detection or credit card fraud or something, right? So this option here, dot, I can now just go with dot. We want to divide the entire stuff by, we are dividing, we want to get the percentage, right? So to get the percentage, you just take the entire stuff divided by the shape of the data set. It's going to be the first one, 0, right? And then now after getting this, you're going to now multiply it by 100. So if I go back and I check it out, so this is it. So 1188, which is okay, but you can use it like that. Okay, now let's move on from here. This is an imbalanced data set, right? But we can leave it like that. Now we have seen how our data set, like, let's check the distribution for the entire stuff. Right, so the simplest option, just go with df dot. You can use this plot, but you can also go with hist, and you plot the entire stuff using histogram. It will take some time. The reason it's giving us all of these things is because of how, yeah, that is why it's giving us this. But you can make it better. This doesn't look nice, so you can just put inside PLT dot. So PLT dot figure size. Let's put that 2010. Then I'll just put it back again. PLT dot show. You can also put the figure size inside the hist and still going. Yeah, you can put this one, this here. It's still going to work, right? You can put it anywhere. Yeah, perfect. So it's working. So this is it. So as you can see, because you have encoded it, you can see the age distribution. Most of them are around 40, in between 25 to 40, right? This is normal. And then you can see the marital status, right? Single, married, divorced, like all of these things, right? As you can see, very interesting and very insightful, right? So you can actually normalize them, but it's going to take a lot of time, and we do have. So let's move on from here, and let's take one of them out. So as I said, we'll be taking out the negative one. We don't want any problem, right? So let's move on from this stage. You can also do feature selection. So let's see the correlation plot. Correlation plot for the data set is going to be my SNS. I'll just go further with my core matrix. It will be df.core, right? And then from here I can just go with my SNS. Let's print it out. Correlation matrix, right? To see if there's correlation between our data set. Perfect. As you can see, let's plot it out. So it's going to be my sns.heatmap. Heatmap. I'll pass in my column, but it's going to be this is how just pass in my core matrix, and let's annotate it. Annotate. It's equal to true. So this is something simple to help us make it better, right? So you can actually expand it to make it bigger, but this is okay. Yeah, you can see it well. It's not that clear, but you can see it well. So let's put some plot in there. So in case you have any question or contribution, you can let me know. And if the audio is getting lower, plot the show, let me also know. So plt.figure, and I'll pass in here. It's bigger enough for you to see. So you can actually get based on the correlation, you can pick some of them out, right? Some of them are not important. You can also use recursive feature elimination to pick the most important ones, the ones that are not important. So Okay, so let's do some simple feature selection, right? We're doing some simple feature selection to make our work easy. We can use all the features, but let's try and see it, right? So it's going to be my feature selection. So feature selection, I want to select some of the features from it, and we are using select key best to help us with that. So I'm just going to be using scikit-learn to select some of the most important feature. I have created a simple function which I used from the previous tutorial, which is going to help us with it, right? So what it's going to do is it's going to take the features, the labels, then we are going to make some predictions, right, for the entire stuff, right, to select the best feature. So let's get our S features. So we have already encoded our data set. I know this is our data set which I've already encoded. We only need the feature, right? Only just. So we only need some of them. So I'm just going to pick the one that are features. So dot columns. You can also use pop to help you with that. So I'm just picking from the age till Y, right? So it's going to be my S features. So df. So this is going to be all the features, right? So let's go to S features. Perfect, right? And then now we are going to have our Y labels. So Y labels, it's going to be my df.y, right? Perfect. So everything is encoded. Now let's apply this function. So let's call it as my best features. Best features we're going to use, right? It's going to be this option, my select key best, and I'll pass in my S features. I'll pass in my Y labels, right? So using chi-square to help us with that. It's going to, hopefully it's going to give us an error, but you fix it. So input S must be non-negative. So see what I was saying, that because we had a negative number here, I don't know whether you remember, there was a negative number here, as you can see. Let me show you. Where was the negative? Okay, there, here, right? There was a negative number here. This negative column here, cons config. So we need to take this one out, because if we don't take this one out, it's always going to give us an error. So we have to just take it out. That's the only one that was having a negative. That's why it's giving us that particular error, right? We can convert them to absolute values, but if you convert them to absolute values, it's going to affect some of them. So let's take off this this one. I take off it, right? We don't need it anyway. There are a lot of features, we may not need it. So let's fix it here. Right again. Yep. And now let's go back and check it again. Hopefully there are no negative values there again. Oh, there's also another negative values. So let's see. Yeah, there are still some negative values, so it's going to give us some problem. Yep, I found it. Yep, my camera has been freezing. Yeah, I need a better system. Okay, so I found it, right? This is the negative one. There are some negative ones here, so I still have to take it out. Employment variation rate. Yeah. Okay, so I have to take it out from here. This one too. We're taking off this one. Hopefully there's no negative values. Otherwise, you see how sometimes doing these things can be. This is just still one part, right? You're not building a model yet. This is just one part of it, right? This is just one part, not the entire stuff. Hopefully there are no negative values there. Then let's run it again. Hopefully it's able to get our values. Oh, voila, it was able to give it to us, right? So we have taken 2 on now. So let's check our best features. This is going to be our best features that we have so far. Computing them perfectly well. And then from here, there's a data frame, right? So there's a data frame, the feature name, feature score. In case I want to get the most important feature, I just go with dot n largest. So as you can see, take the number of columns. So I want just, we have about 17. We want just 10. Let's keep 10. Or let's keep 12, right? 12. Then the number of the columns, right? Just go straight away with this, right? No, backwards. And I can now pass in the column that I want. So this is the column that I want. Let's go with the feature scores. So let's check it out. I want to just get the 12 most important ones. So these are the 12 most important. So duration is very important, followed by payday, number of employees, this one, previous age, all of this. So these are the 12 most important features we can actually use. Yeah, I've taken off the camera. These are the most important features we can actually use for our task, right? So just a first 12 one, right? Very interesting. You can also make it 17, as many as you wish, but I think this is okay, right? So let's go back again and then get them out. Then go back and get only those features, and then use only those features for our work, right? So the number of features we have is, how many do we have? We have 21. We are just reducing them to, let's reduce them to 12, right? So dot columns. I think it's not columns. You're supposed to get this one. Get the feature name column, then to list. So these are the ones we use. We can make it 15. Let's make it 15 instead of, otherwise you are reducing a lot of them. So let's make it 15. Okay, just 15, right? Yeah. So these are the ones we are using. So this is what we'll be using for our work, right? For our task. So we can actually use these ones as the features we want to use for our training data set, or we can just move on to the other ones as you wish, right? So let's go back again, and then let's create our new one. I'm going to call that my S. Right, it's going to be my S. Let's put as S selected. It's going to be my df, and I'm going to pass in these names there. So this is already to list. So let's call this my best features. Yep, right. So we're using these ones to help us with that. So this is what you are using, right? Very simple. So if I go back and I go with S selected, so these are the features you are using for our work, right? Very simple. Okay, so this is what you are using. Now let's build our data set. So we are done with it. So the next task is to split our data into training and testing. So we are done with it. We can actually scale them, right? We can normalize them because some of them are too huge. Yeah, I think it's better we normalize them because some of them are too huge. We can normalize them or scale them anyhow we want it to, because these values are too huge. Otherwise it's not scaled. So let's do some normalization. So this is still going to be normalization. Going to normalize the data set. Oh yeah, scaling data set, right? So you can use standard scaler as you wish. Scaler can use min mass scaler. So this is a normalizer. So let's use the min mass scaler. Min mass is going to, let's use standard scaler, right? So it's going to be the same thing. So from scaling dot processing import standard scaler. You can also use min mass scaler if you want, right? And just create our scaler, which is going to be my standard scaler. And I need to fit it to my data set, right? So, and one thing you have to know is that you can scale the data set, right? But if you are going to scale the entire data set, you're going to have data leak, right? So in order to not affect the entire data set, let's split it first before we scale them. We have to split the entire data set first before. So this is going to be my split. This is going to help us to prevent data leakage, right? So that is the basic understanding, right? So I'm just going to go with my train test split. So it's going to be my S train, all the S together, all the Y together, S test, Y train. Let's see what I did. y train, y test. Then I'm going to go with my train test split. I'll pass in my s selected, my y labels, and then the test size. Let's go with the same thing, 0.3, right? And you can also specify the random state as, let's say, 7 or 42, okay, right? Perfect. Right, you have split the data set, so now we can actually scale them. Right? We can scale them to make our work easy. So I'm going to scale it. Go back again. So this is going to be my S train. Scaled, right? And my Y train. Scaled. So to scale it, you must first of all fit the entire data set before you work on it. So it's going to be my option. Right, so to prevent data leakage, right, as I said, you have to split before you scale, right? You have already done that, but you need to be able to work on it. So let's do it this way. Come back again. Yep, and then let's, first of all, you must fit it before you transform it, right? So back. Okay, so let's see how to do that. So let's first of all transform the data set, fit it first. So fit, so to learn from it, it's going to be my sc, right? Dot fit, not fit transform, just fit on the S train. Right, so it's going to learn the representation from that. That is going to be the first thing. Perfect. Now after that, I can now transform it on the S and then on the test, right? That is the basic understanding. So I'm not going to even scale the train. We already just, yeah. You're not scaling the Y train because you can't scale the Y train, of course. So let's go with this option. Then I'm going to go with my sc dot, this time going to be transform. You can just do fit transform, but I prefer to do it fit first, then I'll pass in the particular stuff I want to go, which is going to be my S train, right? So this is going to transform the entire stuff. You can just do it one fit transform straight away. So let's check it out. So if I go back and I just go with my S train dot head, you can see it. You see how it is, right? Now let's check the scaled one. So S train scaled dot head. Let's see the difference. So you can see from here, from our data set, that I'm making a mistake somewhere. It has no, I have to now, yeah, I've scaled it, but I can just put them back again into the right data frame. That is what I forgot to do. So let's do it here. Come back again, convert the entire stuff into data frame so that we can be able to use it, right? So convert to df. So it's simple. We have my S, between my S train, right, scaled. It's going to be my pd.data frame. I'm going to pass in my S train scaled, right? Then there's going to be the first one, then the column name. So column, I'm going to pass in my S train dot columns to list, right? So that we get it perfectly well. Perfect. So now it has been scaled, everything is perfect. So if I go back again and I check it out, you can see the difference, right? Wow, it's having a lot of negative numbers, and since there are negative numbers, we may have some problem, right? We may have some problem because we scale them, right? And as you can see, right, there are some negative numbers there. Right, very cool. We have scaled the data set, yeah. You can see the difference between them. So let's normalize instead of scaling. Let's change this one. I want to just change it from this to normalizer, min-max scaler. Yeah, let's try that one out. I don't want to get negative numbers. I don't like negative numbers. Let's go back again, transform it, transform this one. Let's check out the difference. hopefully doesn't give us this is better, right? So since there are no negative numbers, you can use this one. I don't want negative numbers. Okay, perfect. Now we have scaled our data set, right? We can also apply the same thing on our test data. So let's apply it. Data, because we have scaled them, now it's going to be my S test, right? Scaled is going to be my, now I can just go straight away with my sc.transform. So it's going to use the same concept to be able to transform this data set, right? And I have to do the same thing as we did above. Convert this one again, just as we did. We are going to apply this one here, the same thing here, to get it back as data frame. So you can feed it into our model. So this, now this is going to be my test, and this is going to be my test, and then this is going to be test. Okay, perfect. So that everything is back as normal. Perfect. So we are done. Now let's move on from here. We have been able to split our data set. We are working everything. We have done with the splitting. Now let's move on to building our model. So as we saw earlier on, there are some things that we need, right? For the component, we need the input layer. We need to define them, the number of features. We need to get the number of hidden layers. We need to get the number of classes, right? So how do we do that? So that's what we're trying to define here. So this is going to be our model building. The next step, right? Perfect. So this is going to be our model building. So it's simple, right? We need to be able to first of all define, specify our parameters, all the various things, all the requirements that we need. So the requirement we need to get the input side. So this is going to be the number of input side. We have our data set, which was my S train, right? We want to get, I want to get the number of columns, so it's going to be my shape. If I go with this one, we have it here. So 15 is the number of input we need, right? The number of layers we need, right? So that's going to be my input number, or we can call it like input dimension. Okay, let's make it like that so that it looks different. It's going to be 15, right? Perfect. Now you also need to be able to specify some other parameters like the output, right? So if I go back again to my data set, it's going to be my, let's print out the y train, right? Dot unique. I check this one out. Is 0 and 1. So since it's 0 and 1, we can specify it as a binary problem. So this is now a binary problem. So this is making it look like it's a binary problem. This is a binary. So since it's binary classification, right, we will need to use, for the loss function, we have to specify the loss function is going to be my binary cross entropy, right? Because it is binary, right? Very simple. That is the basic understanding. And then the output now is going to be, since it's binary, we can just put it as 1, right? Because it's just 0, 1, right? Very simple. So this is going to be our output. So output going to be 1, right? So you can make it like this, number of inputs, or you can make it like number of inputs dimension, output dimension, anyhow you want it to be, right? Output number, input, as you wish, right? Now let's, first of all, from here we have done the most important thing. So we need to be able to define, we have building a model. So first of all, the next step is that we must define the model architecture, right? So we are using sequential model, as you can see from the diagram that we had. So we have finished with this. All that we did, we were doing this. We need to move on to the define the model. So we're using sequential, then we compile the model, we fit the model, evaluate the model. So let's go back again and see how to do that, right? So we just be importing everything from Tensorflow Keras. So it's going to be like this. So from Tensorflow So one of the things, like before you define the model and build of them, there's one thing you can also do to be able to visualize this. Visualize our tensors, right? And just go straight away with this option of specifying the, like, to record the what do you call it, tensor board, right? The tensor board, which you can do later. So we can visualize the tensor board later, right? We can do that later. So in case you want to do that, you just move on. We will do that one later so that it doesn't affect us. But let's build the model first, right? So we'll be building the model first. But in order for you to do that, you have to work on that one later. So this we will do it later. So let's start with this. So we want to define the model, load in our packages that we're working with. So the first one we're going to be loading is our, so from Tensorflow .keras, we need to import some other things to make our work easy for us, right? So these are the things to be imported. We have already, remember that you have already imported Tensorflow. So Tensorflow.keras import, we are going to be importing sequential because we are building sequential model. Then from Tensorflow .keras, keras is the higher API, keras import dense, right? You can also add, let's say, dropout, back propagation, all of these things. So from Tensorflow well, let's not go, let's just pick the simplest option that we have, right? Let's do the simplest option. Let's say from Tensorflow. We want to, this is a very nice thing that we can do to help us visualize what we are doing, right? To be able to make sure that we see utils, right? To get .keras, I don't know why I can't spell .keras .utils import plot model. So this is to help us visualize the network, right? And this is going to be our deep learning libraries packages, right? So these are the various things to be using, right? Sequence, I made a mistake somewhere. I made a mistake. The mistake I'm making is that it's supposed to be .layers, right? .layers, and then see what I did. .layers, yeah, right, perfect. So we are importing sequential, we are importing dense from the layers, right? Perfect. So let's build our model, right? So it's going to be very simple. So it's going to be this option. So we want to define a model. So we define model. It's going to be by model that I have. I'm using a sequential model. Sequential, right? That's the first thing. Perfect. And it's going to take some other stuff. It's going to take some parameters. So model.add. I'm going to pass in my dense layer. So dense layer can be any, right? Any number of layers that you want it to be, right? So let's specify, like, since we have our input size of 15, yeah. So let's make it like, let's say you can make it like 20, right? It doesn't matter, right? Then now I'm going to specify the activation function. It's going to be, let's use ReLU. So there are different forms of activation function. We have ReLU, we have step, we have sigmoid, we have tanh, right? All of them. But the activation function is what's going to sum all the various ways of the input to give you to give you the right result, right? Just to measure that, to make it better, right? Okay, and then let's specify a kernel. Activation kernel initializer. So all these parameters, see, so these are the various parameters, right? As you can see from here, we have activation function, right? We have the bias, in case there's bias, kernel initializer, right? Which is the next one we are trying to do. We also have kernel regularizer, we have bias regularizer. There are different parameters that you'll be using, right? But you will not be using all of them. You're just picking, allowing it to be the default, and then you're just picking the HE normal, right? So this is going to be our kernel initializer, and then this is going to be HE normal, right? You can just keep it like this, right? Perfect. We are done with this one. So the next one we are supposed to specify that we want to specify the input shape, right? Which is going to be the number of features we have, which is going to be the input dimension. So input dimension, right? So that is what you're trying to do, right? Very simple. So this is going to be our first layer. We also need to add more to it, so let's copy this one here. So this is going to be our output layer, right? Most of this is very important. Any place you see the input shape or something, that's going to be our output layer, our input layer, right? Then you also need to create other hidden layers. So this is going to be a hidden layer. So I'm just going from 10, and I can just move from 10 to, let's move from 10 to, let's make it like, let's say 16, right? You're just reducing it by 4, right? It can be anyhow you want it to be. And this is not going to take in, this is just a hidden layer, so we don't put in dimension, right? This is just a hidden layer, as we saw from the diagram here, right? Now let's use the better diagram, right? So we have it like this. So this is our input layer, which have the number of features. Then we also have the hidden layer. So this is what you're trying to create, an output layer, right? So we have given the number of features, which was 15, because we're using 15, and then this is going to be the hidden layer. So this is what you're trying to create. Then later on move on to the output layer. So you can use a formula, this particular formula, to get it, right? You can use it or you can just ignore it. So let's try it out. So I'll just go back again and let's try the formula. I'll try it somewhere and then you come back, right? Right. So let's move it like that. You can actually use a formula, right? So I'll just put the formula here. This is a simple formula, right, to help us with that. You can use this formula, but yeah, so let's give an example. So let's say you're using this example, right? Example. Let's say for iris, this is for iris, right? For the iris dataset, we have, say, get hidden layer neurons, right? This is just off topic, right? For iris, it's 150, right? The sample size 150. The number of input was 4, right? Separ length, separate. And then let's say the number of output was 3, right? So if I go with this option, it's going to give us like 12 or 10, right? So you can actually specify the dense layer as 10 or 8 or something, right? This is just off topic, right? You should not do this. This is just off topic. This is just to help you with that, right? Okay, so let's move on. So I've set that one for the first one, right? And then you can actually also specify another one, right? You can also add more layers to it, right? If you're supposed to use this one, it's going to be so huge, so you determine it, right? But let's build the most simplest one. So model, this is going to be one layer is always enough. One hidden layer is more than enough to help you with that. Then let's go with model dot add. This is going to be our output layer, or our this particular layer. So just one layer is okay. Output layer. Just go back again, and then I'm just going to specify that this is going to be dense. Can't spell. This is going to be a dense layer. I'm going to specify the number of output, which is going to be my number of output. So output dimension, which we had already, which we specify as 1. Then activation function. So the activation function here, I'm specifying it as softmax, right? Right. Perfect. So that is something very simple. So I'm using relu, and we are using softmax. So activation output here is 1, right? Very simple. So let's go back again, run it. So this is going to, it's giving us an error here because we miss kernel initializer. Keyword argument, we spelled it wrong, so we have to spell it right. We spelled this one wrong. It's not kernel. Oh, see what I spelled. It's kernel. English. Oh boy. So let's fix it. So the error is giving us, as you read from the error, right, it's telling us something. It's saying that the int object is not iterable, right? Iterable. There is batch size, all of this code. So how do you fix it? So the issue is from here. The inside, this must be in a format of a tuple, right? Something that you can iterate over. Right, so this is it. So it must be in a format of a tuple. It must always be in this particular bracket. So since it's giving us an error, let's make it like this. I'll copy this one to make it iterable, right? Something easy for us. right? So because you already know what this one is, so print input, yeah, right. If I check it out, yep, 15, the same thing. So right. So can somebody tell me the error? So the reason this doesn't change anything, right? This doesn't change anything, just to help you know the stuff. So you know that in Python, right, the reason you're having this error, you're having this tuple error. Very funny. That's one thing about Python, yeah. The reason you're having this particular one here is that in Python, if you go back to this option, let me show you something. If you do this, right, if I have a number, this number, right, if I put this number here, let's show you something. So 1, this is going to be give me as 1, right? If I check for the type of this, so type of this number, this is going to be what? Integer, right? Perfect. But in case I want a tuple, right, I have to make it like this. So print type, then 1, right? This is in a comma. So putting something inside this option here. If I put this one, yeah, I'm trying to explain a lot. If I put this one here, right, this is now this entire stuff. This thing here is a tuple. This is a tuple, right? You should not forget this. So if I go back again and then I put everything back and I copy this one, put it back here, you can see the difference. So the first one is going to be an integer, but this is now a tuple. This entire stuff here, right? This entire stuff now is now a tuple. It's no more supposed to be this option. This one here now is now a tuple, right? So it's supposed to be this option. So by this putting inside this, it becomes a tuple. So I have to go back again to here. That's why it's giving us this error. I'll go back again and I have to put the comma here. Something very simple. Hopefully it works. If it doesn't work, oh, see, wow, see that it works. See how we have faced this issue just by understanding the basics, right? Okay, this is just face error via for tuple, right? So this is something, this is very basic stuff, right? That helps you to know. So just by that, we face that error, right? Now we have finished defining our model, right? So that's the first step here, right? We have built our input layer, our hidden layer, our output layer. Now the next thing we need to do is to move on to this step of compiling the model, then fitting it. So let's compile the model. That's going to be the next stuff there. So let me put all of these things together. Put this one here, right? So this, let's hide this one for future people. And now let's come back again, and I want you to define or to compile. See how I spell it? Compile. How do you spell it? Compile model, right? How do you compile the model? Very simple. Just go to the model dot compile. This is very important. So the compilation is going to the compilation simply involves calling a function to compile the model with some specific chosen configuration, right? So we need to specify the optimizer. As you can see here, there are several optimizers. We need to specify the loss, you need to specify the metrics, you need to specify all of these things. But let's go with the simplest one. So I'm just going to specify an optimizer, and the most commonest and most powerful optimizer is Adam. So Adam is very useful because it's an adaptive, or how do we call it? Yeah, adaptive model or optimizer. So go back again to compile. So the requirement for this one is that we need to be able to specify an optimizer, right? And the most commonest optimizer we know is Adam. So Adam is adaptive, something I've forgotten, but it's very, very powerful, right? There's also softmax. There's Adam. There's also Adam. There is a lot. There is there are a lot, etc. Right? There is also SG. These are the famous one, SGD, stochastic gradient descent, very also powerful. So these are the most commonest ones that we use, right? So Adam is very useful, it's very adaptive to most models, right? Perfect. Then we need to also specify a loss function, which in our case, this is a classification problem. So it's a binary classification problem. So I'm just going to specify the loss as binary cross entropy, right? Every binary problem must go with this, right? Every categorical problem go with categorical entropy, right? If it's regression, you specify that one also. Then I also have to specify the metric. So the metric I'm using, I want to just use accuracy because it's classification. Accuracy, right? That is all, right? So this is going to compile our model. So we have Adam, we have binary cross entropy because it's binary problem, we have metrics because we want to check for the metric, and now we can also virtualize the model. So how do we virtualize this model? So simply just go with this option. Before we virtualize, let's get the summary of it to make sure that everything is working well. So to get the summary, just go with model.summary. This is important to know how many layers, how many was there, right? So as you can see from here, we have gotten our summary. So we have our output layer, right, shape, right? We have our dense layers, and we have the parameters and the rest, right? Very, very important. So this is going to be our output layer, and then the various ones, this is going to be our input, and then the rest, right? Okay, so let's go back again, and then we can also visualize this entire stuff. So in case I want to visualize this, the model, see what I did. Yep. In case I want to visualize this, it's very simple. It's very important sometimes to visualize the model to see what it is. So just go with my plot model. Then with the plot model, I can just pass in these particular parameters. I'll pass in the model and the file I want to convert to and if to show the shape or not. So I can just copy this stuff here. That's one thing I like about Colab. Okay, so I'll come back again. I'll paste it here. So we have our model, which is the one we have to file. So let's call it as my bank predicting model, right? Bank 10 prediction model, and then I can specify that, okay, show shapes, I want to specify it as true, right? And that is all. So let's run it again. So the plot model is coming from here. Remember we imported it from here, right? So you're trying to plot the entire model to see the graph representation of this particular model that we have, right? So as you can see, we have our input layer, right, which is having 15 different features, right, for the input, right? And then we also have the dense layer, right, the next layer, the hidden layer, 2 different hidden layers, and then we also have our output layer, right? Very simple. So this is something very important to help you with our work, right? Makes you visualize. You can also use TensorBoard to also do the same thing, right, which we'll be talking about that one later. But let's compile stuff. So we are done with compiling, we have visualized it. Let's fit our model and evaluate. So to fit the model, just go back again. Let me pass this up step here. Well, this video tutorial has been so long, so fit model. This allows you to be able to identify patterns. Identify the patterns between the features and then the label, right? This to help you with this, just to learn the relationship, right? Like this is where the actual training goes over, right? This is where the training is. Okay, so let's go back again and see how to do that. So I'll just go back again to this option. Now in training, we have to specify some parameters, right? So the parameters we need for this one, this is going to be the parameters we need to know is that we need to get the epoch. So epoch, right, as the name goes, epoch is just the number of pass-through, so number of iterations or pass-through for the data set, right? So for the entire data set, right? And we also have batch size, right? We also have verbosity, right? So these are all some of the parameters you have to pass. So the batch size is the size of the data set, right? And we have the number of iterations or pass through for the data set to train by, right? So let's go back again and set it out. So I'm just going to come back again and I'm going to fit the data set. So fit the model. So model.fit. Now pass in my data set, which we have the S train scaled, remember, and then the Y train. Then I can specify the epoch, number of iterations, epochs, not epoch. There's S there. I can change S, and I can just specify. So let's give it a simple epoch of, let's say 10, right? We don't want to, it's too huge, so let's make it just 10, or like I make it 5, anyhow I want it to be, right? You don't want to take a lot of time. Then let's specify the batch size. You can also specify the batch size, but let's specify 32. Leave it like that. Just put 32, but we'll talk about that later in the future. And I want to specify the verbose as 2. So verbose 2 means that show it, right? Let's go back again. So for the verbose, it's like this. We have verbose. We have 0 means no show, no display, and then we have 2 means show, right? Show, right? Something like that. 1 means show. So 1 and then 2 means you show it at different levels of verbosity. Something like that. Say something like that. Yeah, that is it. So let's run it again and see. So I'm just using just 5 epochs, right? We can change the epoch, but I'm just making it 5 because I don't have time. So it's going to run it the first time, second time, and as you can see that as it goes up, the accuracy of the model goes up, right? See that it's very low, right? The loss is low, but let's put it to 50. Let's change the epoch to 50 to see whether it's going to increase. It's going to take some time. Take some time for it to run. So it takes some time for it to run, right? So you can go and have some chai or some coffee. So after it has finished training, the next thing we'll be doing is that we'll be trying to evaluate the model, and then we'll try and serialize it, right? Save it. Okay, so that's finished. Now let's evaluate it. So this is going to be the next step. I'm going to evaluate the model, right? So how do we do that? So it's very simple. We'll specify my loss and then my accuracy, right? It's going to be my model dot evaluate the model. I'm going to pass in my S test scaled. Remember that you have scaled it already, and my Y test, right? And I can also specify the verbosity. So verbose, go to 0. So this is going to give us our result. Now in case I want to check for the accuracy of the model, right? The first one is that via the accuracy of the model, right? Perfect. So how do I do that? Just going to go with my ACC. You can see from here that the accuracy of the model is, let's check it out. Oh, it is so low. 11%. Yeah, it is so low. Remember that this data set is imbalanced, right? So the model it's very good, but it is low, too low, as you could see from here, right? The same thing. It is too low, so we need more data, right? Okay, now let's move again from here to check for some other stuff. So what again can we check for? We can also check for the loss. It's going to be the loss that we had, which is almost going to be similar to this one that we had here, right? So this result is what is being displayed here, right? The best of them. Okay, so we are done. So sometimes too, it is advisable for you to, in case you also want to make a prediction, right? You can also do the same thing. So in case I want to make a prediction, let's try that one out. Right, I'm going to make a prediction for what you have done so far. So I'm going to be picking something from one of them, right, to use it to make our prediction. So I just go back to the S test skilled, right, .ilog. Let's pick this one. So this is what we are trying to use, right, to make our prediction, right. So I'm just going to put this entire stuff as example. So example 1, right. This is what we are trying to use. So print example 1. Right, so this is what you're trying to use. Perfect. Now let's get the expected one. So this is going to be the expected value that you are looking for the same thing. It's going to be my y test .ilog 0. 0 0. So this is going to be 0. That means that this person is going to not subscribe, right? This is no. Okay. So now let's make our prediction. So to make the prediction, it's going to be very simple. So let's predict. So it's going to be, first of all, in order to predict, you have to reshape dataset, right? So in that case, it's going to be like this. So sample 1, and I'm going to reshape it. So numpy.array, I'm going to pass in my example 1 dot reshape. I'm reshaping it as 1. Right, so I have to reshape the entire dataset so that I'll be able to see it. So let's print it out. After reshaping, so if I print this one out, this is the reshaped one, right? So this is the option we are trying to use. We are using this particular reshaped dataset in this particular format to be able to make our prediction, to feed it into our model, right? So now I'm going to call this first. You must get our probabilities, right? So it's going to be my probabilities. It always keep probabilities first before you get the prediction. Probabilities. Then I'm just going to go with my model dot predict. I'm passing my sample 1. So this is going to be the probabilities. It's always going to give you the probabilities. If I check this one out, probabilities. Can't spell probabilities. And it's going to give you a lot of numbers, right? I spelled it wrong, that's why. See how they spelled it? Proba. Okay, so we give us as 1, right? That is the probability it gives to us. So if you check it, give us a probability of 1, right? Now, in case I want to be able to know the actual prediction, so actual prediction, I have to use argmax, right? So I'll just go with this np.argmax, pass in this particular list, and as you can see, this is 1, but if I check it out, it's going to return 0, right? The argmax, right? So this is the actual prediction, which is exactly the same thing that we had here, right? So that means that our model is predicting well, right? It's predicting well, it's not making a mistake. Very simple, very nice. Okay, now let's see how to save this particular model. So how do you save this model? In case I want to save the model, how do I do that, right? To save the model is very simple. It's going to be my model.save, and I pass in this particular option. So the name of the model, so let's call it as my bank term predictor model. And as I always do, I'll put the date. Today is 8, so 8 August 2021.pql. We're not using pql, we are just using h5, right? So this is going to be used to save this particular model. So that's how to save the model. We're going to be saving the model here. It's giving us an error. Unexpected indent because I did not indent it well. Back. I left some space here. Okay, so it's going to save the model. It's going to save the model here. As you can see, just save the model, and now we can actually use this model to do whatever I want to do, right? It's going to be showing here. Perfect. Now let's load the model. In case I want to load the model to use it for something else, so let's go it from Tensorflow. Right, .keras .models import load model. Yeah, so use this particular one function to help us load the model back. So I'm going to call it as my new model. I'm going to go to load model. I'll pass in my saved model, the one I serialized. Pass it here. And I've gotten back the model. I can now check for the summary of this model. So new model summary. You can get back. I spelled it wrong. I'm typing faster because of the time. Check it back. You can get a summary of the entire model, right? So it's going to be this option. Yeah, let's run it again. So this is to get a summary of the model, right? So that means that everything has become back, and I can actually use it to make some prediction. That is how to work with this particular option. Now, sometimes it is advisable for you to plot the curve there, right? The loss curve and all of these things. So how do you do those things? So I'm just going to go back again, and then I'm going to do some simple visualization. Right, so in case you want to visualize it, you can just do it in this option, right? So the simplest way is that I just go back again to the model that I had, where I fitted the data set. So let's call this one as history, right? In case I'm model.fit, I'll pass in my S-train scaled, my Y test, right? Then from here, I'll just go with my epoch. So yeah, so in case you want to get this one, you're not using the S-train, you're using the entire data set, right? You'll be using the entire data set instead of using the S-train, because since the reason that you'll be specifying the validation option, right? So this is how to do that. So in case you are trying to do this, right, since you are splitting it, you use the actual data set, right? I'm going to use the actual data set, not the splitted one, not the train test split, and the actual Y labels, right? That's the basic understanding. I'm going to run it. So I can run it as 50, I can run it as 30, anyhow you want it to be. So let's make it 50, and let's run it again because we use the one at top as 50. Could take some time for it to run. I specify verbose as 0, so that it's not going to give us any result in our terminal. I want it to be clean. Then later on, after it has done everything, I'm just going to use this particular one to plot it, right? To plot it. I'm going to plot the entire stuff, right? To plot the learning curve. So this is not just visualize training. Did I call it less curve? It's supposed to be, yeah, you can call it training curve, but you can also call it learning curve. It is learning, so the learning curve, right? So it takes some time for it to run. To that, after that, I'm just going to go with my history. So the history is going to be in the format of a dictionary, so you can also get everything out, right? You can get the loss function, you can get the validation call, all of these things from there. Perfect, so that's finished, right? So it has finished. Very simple. This is me. Yeah, I'm back. Now, if I go back with the history now, it's going to give us a very huge amount of data, which is, this is like in the format of callbacks. If I go back again to this is like a dictionary, right? So if I go history, it's like a dictionary. So I'm going to get everything back, right? So these are all the various things. So I can get the loss from this, right? Get the loss functions, and I can get the rest, right? So in case I want to plot the entire stuff, I can come back again, paste it here to save us time. So what you are doing is that you are just going to plot the loss against the validation loss, right, for the training. Takes the time for it to plot it. So let's see what we have. Oh boy, this is so bad. You see how it is. So it was not even learning as much as it's supposed to learn. This is a training, and this is a loss, right? It's going just like that. No, it was not learning as much as it was, right? So that is something very simple. So see how we built it, right? So sometimes, in case you wanted to learn, well, you now come back again to this same model that we built, which we'll do it another time. You come back the model we built here, right? This particular model, and you can add the dropout, right? So you can actually specify a dropout, right? So you can also add dropout to see how it's going to do. And the dropout is very important, right? You can put it on the, you can put the dropout here. Come back again. So the dropout can be placed in the hidden layer, in the input layer, on the hidden layer, right? Before or after, right? Any of them, right? It depends upon you. So let's go back again and try that one out. But before you try that one out, to make it look better, we can now let's try that one out. I'm just going to go back again, layers dot dropout. Let's import it, and then I'll just go back again, copy this one, and I'm just going to go back and try that one out, right? So I'll go back and try that one very fast. Then later I'll move on from using TensorFlow, right, to move from here to go on with scikit-learn, right, to see the difference. So this is using dropout on visible input layer, right? So this is the first one. So I'll just go back again, the same thing we did, right? The same thing we are doing. I'm now going to go back in the visible layer, which is this one. I can also specify a dropout here. That is a basic understanding. You can put a dropout here instead of the dense, right? Okay, so I can actually add a dropout. So as you have seen, I just copy the code to save us time, right? Module 2, I'm adding a dropout at the input layer right here. Then I'm running it, right? You see, it's going to take some time for it to run and give us our results. You're going to see sometimes adding a dropout in the visible layer, input layer, or the hidden layer will improve or make some changes, right? That is just by the way. So whilst it's doing that, you move from here to do the one for scikit-learn, right? That's going to be the next thing. I just wanted to see that you can also add a dropout. It depends upon you. So you'll be trying to do it yourself, finding out which one of them is best for you. So I'll go back again, and then let's build a multi-layer deep learning, right? I'm going to call this one as deep learning with scikit-learn. Deep learning with scikit-learn. You can also use scikit-learn for that, as we saw. Right? So we're using multi-layer Perceptron classifier. That's what you're trying to use, right? So it's very simple. We have already imported it. So let's import it again. So from sklearn.neural networks. Okay, it has finished. And this one is still the same. We did not even do any much improvement, as you could see. Right, not as much improvement as you could see. So let's check it out. So I'll just run it again. It's 2 and accuracy. We want to check and see our results. So print for the loss, and then print for the accuracy to see the result. And as you can see, it's not that good, right? So it depends upon you. You are supposed to design it rather. Okay, so let's move on to the next one, which is how to do deep learning with scikit-learn, right? So how do you do deep learning with scikit-learn? So from scikit-learn.neural networks, we are going to import multi-layer Perceptron. It's multi-layer classifier, right? Multi-layer, yeah. We have regressor, we have multi-layer Perceptron. Very simple. Then I made a mistake here. This from sklearn.neural network. Yep, and from here I will be working on, just like we do most of the time in scikit-learn, initialize. It's going to be my MLP NNN, right? Then I'm just going to go with my multi-layer Perceptron classifier. Right, initialize it like we always do. I know you can even just leave it by default. You can also, as you could see, there were some parameters here, right? Let's go back again. There are some parameters you could put there. It's a hidden number of layers in case you want to get it. Activation version, you can specify the solver. All of these particular stuff, you can also specify them, just like we did previously, right? You can also do the same thing here, right? But let's leave it at the default. Okay, then after initializing it, you just go back again and then you fit your data set to it. So MLP NN.fit. But let's go back again and make some parameters. Let's add some parameters here. So I want to set the maximum number of iteration to the other one we did was like 50, right? But let's multiply it to, let's make it 50, and then we can also specify the random state. So random state of, let's say 42, so 42, something like that. And now I just go back again and I'm going to specify that string skilled, and y train. This is how to do that. The same thing is going to work, right? You can specify the maximum number of iteration to be 300, to be as much as you want, and then you can just check for the score. So that's finished. So it's giving us some error. So this is going to be all the things that you used, right? And you can see that we have the batch was set to auto, activation was relu, just like we had the hidden layers, 100 layer size, and the rest, right? So I'll just go back again and check for the accuracy of this. This is going to be the same thing. So multi-layer perceptron and then dot score. See, it's very simple, right? Then just go with s test skilled, then export it wrong, then y labels, y test. So if I check it out, it's almost going to be see that you can see that even the multi-layer perceptron classifier give us a very high accuracy than the deep neural network. Wow, very interesting. This is because of how we architectured that one. But in case with the same thing, the same good architecture, it would have been better, right? Very simple and very nice. That is something very simple about this. Very cool. You can also use this one to make some prediction. It's also going to work as expected. You can also pass this one here. So multi-layer perceptron n.predict. Now passing my sample 1, and it's also going to give us a prediction as what? 0, right? So it's, although the deep neural network with TensorFlow gave us was having a lower accuracy, it gave us the same prediction, right, as we had. So that is something very basic we have done so far. So to recap, we have seen in a long way how to work with neural networks, right, from scratch using TensorFlow. You have seen the difference between a biological neuron and an artificial neural network. You have seen the components of a neural network, which we have the input layer, in case you want to know the number of layers or the number of nodes or neurons for a particular input layer. Is going to be the number of features, or the number of features plus 1 for bias. We have the hidden layers, and we saw the formula we could use to help us get that. We also have the output layer, which is going to be the number of classes. If its regression is 1, if its classification is 1 or more based on the target, and based on the activation function you are setting. Perfect, right? And we saw how to work through this particular workflow. You have you define your model, you prepare your data set, which it took us a long time. You define your model, you use sequential, you compile, you fit, you evaluate, you can tune it, you can productionize. You have seen how to save them. So thank you for watching this long and exciting tutorial. So thank you very much for watching this exciting and long tutorial. I know maybe I was speaking fast, there may be some error somewhere, but in case you see or notice any of them, let me know in the comment section below. And please don't forget to subscribe and smash the notification button so that anytime there's a new video, you may have access to it. And we also have some powerful tutorials and powerful videos on Udemy, on our website, and on Patreon. Check them out for us. And don't forget to sponsor us. See you in the next session. Stay blessed.